When a chemical reaction occurs, energy moves. Energy is required to break chemical bonds, and energy is released when bonds form. The best way to think of this is by viewing a chemical reaction as a system. The reactants and products are part of the system, and the rest of the universe is outside that system. In general, when complex substances are reacted to form simpler substances, the simpler substances will contain less energy in their bonds than was contained in the bonds of the reactants. Since energy can neither be created nor destroyed, that energy has to go somewhere, and it leaves the reaction system and goes out into the universe. The energy exits the system. The reaction is exothermic. Exo means out. Thermic means energy. When simpler compounds are used to build more complex compounds, then the complex products contain more energy than is present in the simpler reactants. This energy has to come from somewhere, and it enters the system from the universe. Energy enters the system. The reaction is endothermic. Endo means into. Because heat is energy, both types of reaction are detected by changes in temperature. If you are holding the reaction vessel, you are the universe. If your hand gets cold, energy is leaving you and entering the reaction system. Endothermic reaction. If your hand gets hot, exothermic reaction. Since energy prefers to flow from a high energy state to a low energy state, most naturally occurring reactions are exothermic. The exception is life. Photosynthesis is endothermic. It builds glucose using energy from the sun. Respiration is exothermic. It breaks down glucose to release packets of energy for cellular function. One definition is that life is the use of energy to maintain complex molecules against the general trend of the universe. Why then does life even exist when it seems so unlikely? Well, take your pick.